Well, in this video, we will go over all the steps for finding second order differential equations, real distinct roots. So we're going to find this real distinct roots for second order differential equations. To solve linear second order or the biggest derivative homogeneous, meaning it equals to zero, constant coefficient differential equation where all y variables must be in the first power. So you know you have a second order differential equation if it's in the form of this: ay double prime plus by prime plus cy equals zero. And it has to equal to zero because that makes it homogeneous. So what I would do first to find the roots is write the characteristic equation in the form of ar squared plus br plus c equals zero, if you can. Okay, solve the quadratic equation, right? You need to know all your factoring rules and your quadratic formula. If you need to review factoring, that's fine. Then plug in into the general form y equals c1 e raised to the rt plus c2 e r2t distinct roots. If given an initial value, find the c1 and c2. Let's talk about the principle of superposition. So if y1 of t and y subscript 2 of t are two solutions to a linear homogeneous differential equation, then so is y of t equals c1 y of t plus c2 y subscript 2 of t, where y of t is of the form of yt equals e raised to the rt. Okay, let's do an example. So this one is like kind of like a proof. So we got to show that y of t equals e raised to the rt is a solution to the linear second order homogeneous constant coefficient. So this one is just a little proof uh, to show that this is this has a solution. So yeah, what do we know? If we go back to, we know that y of t equals e raised to the rt. And then we need to find y prime. So y prime of t, how do you take the derivative of e raised to the rt? Well, it's e to the rt times the derivative of the power. So r, it's like saying five. This is like almost saying five. RT is like the same thing as 5x. So the derivative of 5x is 5. The same thing with RT. The derivative of RT is just R. So you could put an R here. And I think we also need our double prime. So y double prime of t is so this R is like a constant. Do not use the product rule. So it's just going to be e to the rt times the derivative of rt, which is r, and then you have this extra r. They're all constants. So that is going to be r square e raised to the rt. Okay. So now what we're going to do is put it in this formula right here. So we know that it's going to be a, and we know that y double prime is this, r squared ert. So I'm going to replace that with r squared e raised to the rt plus b times y prime. So b, my y prime is r e to the rt plus c times y is just e to the rt equals 0. If you kind of like clean this up, this is going to be a r square e raised to the rt plus b r e raised to the rt plus c e raised to the rt equals 0. So what can you do here? You can take out an e to the rt, and now you're left with a r squared plus br plus c equals 0. And we know this is a characteristic equation. And we also know that e raised to the rt can never equal to 0. So we can conclude that e raised to the rt is a solution to second order differential equation, provided ar squared plus br plus c has a solution. Okay, so that was just a simple proof. Now let's do actual problems. So let's start with example 2. It says find the general solution to the differential equation of y double prime of t plus 2y prime of t minus 8y of t equals to 0. So what would I do? I'm going to rewrite it as this. I'm going to rewrite this problem as y double prime of t plus 2y prime of t minus 8y equals 0. And I'm going to figure out my a, b, and c. So my a's, b, and c are the coefficient. So my a is the coefficient of the y double prime. So this has invisible 1, so my a is 1. My b is 2, because it's the coefficient of y prime. And my c is negative 8. Okay. So step 1, put it in the characteristic equation. AR squared plus BR plus C. And so this is going to be, what we have is, so this right here, we're just going to replace, we're going to rewrite that as, here, let me just sort of block this. We're just going to rewrite it as R squared. So the double prime t is just represented as R squared plus 2R minus 8 equals 0. See? That's all we did. We just replaced the derivatives with the power. So this has two derivatives, so this is the power 2. This has one prime, this has one r, and then this does not have an r, so it's just a constant, negative 8. Okay, step 2, we're going to solve. So this is where you need your factoring rules or the quadratic. And I think we could just get away with it just doing regular simple factoring. So this factors out as r plus 4 and r minus 2, right? Because what two numbers multiply -8 and when added gives you +2? +4, -2. So my r is -4 and my r equals to 2. So what do we know about these roots? They are distinct, meaning they're two different numbers. And they're also real. They don't have an I, so they are real roots. Okay. Now that we found our R, step 3, put it in the general form. So put it in this form. Y equals C1 E raised to the R1T plus C2 E raised to the R subscript 2 of T. So we know that our two roots are -4 and +2. We do not have an initial condition, so we don't have to find C1 and C2. Okay, so our final answer should be y equals C1 E, and then one of my roots was -4, so it's going to be -4T plus C2 E, and then one of my other roots was +2. And there you go. This is your final form. Okay, let's move on to another example. Example 3, solve initial value problems of y double prime minus 2y prime minus 8y equals 0. This time we have two initial condition. We have a y of 0 equals 1, or a coordinate of 0, 1, and then y prime of 0 equals to 10. So we're going to use that to find your C1 and C2. Okay. So first step is put it in the characteristic equation. So put it in the form of AR squared plus BR plus C equals to 0. And my A has a coefficient 1, my B is -2, my C is -8. So we're going to put it in R squared minus 2R minus 8 equals 0. Okay, step 2, solve. So just factor this out, well, you can set it to 0 first. Well, we did. Now we just have to factor it out. I think it factors out nicely. It's R, what two numbers multiply -8 and when added gives you -4. Maybe like 4 and 2. And this is -4 and this is +2. So my R is +4 and my R is -2. What can we say about these two roots? They are distinct. That means they're two different numbers. And what else? They are real, right? There's no imaginary, so it's real. So step 3, try to put it in the general form. Y equals C1 E raised to the R1T plus C2 E raised to the R2T. Okay. So we have our two roots, +4 and -2. So it's going to be y equals C1 E. and then my R1 is 4t plus C2 E, and then my R2 is negative UT. Okay. Step 4, plug in your initial value. So this is going to be one of your initial conditions is y of 0 equals to 1, and then y prime of 0 equals to 10. So yeah, we're probably going to have to do some kind of system of equation. So if you recall, our equation is going to be y equals c1 e to the 4t plus c2 e to the negative 2t. What should we do? We should plug in this condition. Or no, actually, yeah, let's find y prime because we have a y prime here. So let's find the y derivative. So how do you take the derivative of c1e raised to the 4t? Keep in mind, c1 is a constant, so it's going to be e to the 4t. Take the derivative of the power of 4t, so the derivative of 4t is 4, and then you still have the c1. And then what's the derivative of c2e to the negative 2? So it's going to be e to the negative 2t. And then you take the derivative of the power, the derivative of negative 2t is negative 2. And then you have a c2. Okay, so we're going to need that. Now we're going to set up our system equation. So let's plug in the initial condition of an x value of 0 and a y value of 1. So replace your y with 1. And also, our x is the same thing as our t. So our t is actually going to be 0. That's what I meant. So it's going to be c1e 4 times 0 plus c2e negative 2 times 0. That's going to be 1 equals c1e 4 times 0 is 0 plus c2e negative 2 times 0 is 0. Guess you can try to clean this up. This is what's e raised to the 0? It is 1. So this is just c1 plus what's e raised to 0? That's 1, so that's c2. Okay, so that's one of our system equation. Now let's put in our other initial condition. So your y prime is 10 and your t value is 0. Okay, so I'm going to do that. I'm going to replace y prime with 10. And then y raised to the t value, I'm going to replace that with 0. Okay, so this is 10 equals 4c1 e. 4 times 0 is 0 minus 2c2 e. Negative 2 times 0 is 0. That's 10 equals 4c1. E raised to 0 is 1 minus 2c2. E raised to 0 is 1. You have 10 equals to 4c1 minus 2c2. Okay, so this is our two-system equation. Let's put the constant on the right. So let me rewrite this as, let me just rewrite it as c1 plus c2 equals to 1. I'm just moving this to the right. That's fine. The same thing with this. Let's move the constant to the right. So this is going to be 4c1 minus 2c2 equals to 10. Okay, now what do we do next? We're going to do a system of equation. So here's equation 1, here's equation 2. So which variable should I get rid of? I think I'll get rid of the c2 because it's really simple. All I got to do is multiply the entire first equation by positive 2, right? Let's do that. So go ahead and FOIL out the entire equation by 2. So 2 times C1 is 2C1. 2 times C2 is 2C2. 2 times 1 is 2. And then on the bottom, you have 4C1. It hasn't changed, right? Minus 2C2 equals to 10. This cancels. And then what's 2C plus 4C? 6C. 6 or 6C1, right? 2C plus 4C is 6C. And then 2 plus 10 is 12. Solve for C1. Divide this by 6. C1 is 12 divided by 6 is 2. Now we have to find C2. So what I'm going to do is substitute C1 back into maybe equation 1. Now put it in the original. Do not put it here. Put it here. So it's going to be C1. Wait, what's my C1? My C1 is 2. So it's going to be 2 plus C2 equals to 1. Subtract 2. Subtract 2. I get C2 equals to 1 minus 2 is negative 1. Okay. So we have our C1, we have our C2, we have our two R's. So our final equation is going to be y equals C1. So it's like C1, which is 2e raised to the RT. One of my roots was, what's one of my roots? 4 and negative 2. So you could put 4t here plus, and then when my C2 is negative 1, e raised to the power, one of my other roots was negative 2. Okay, so this is your general form, and that's it. Not too bad. So let's move on to example 4. So example 4 says solve the initial value problem of 3y prime plus 2y prime minus 8y equals 0 with two initial conditions of y of 0 equals negative 6 and y prime of 0 equals negative 18. So first step is put it in the characteristic equation. So it's going to be, put it in this form, a r squared plus br plus c equals 0. And I believe our RA is going to be 3. My B is going to be 2. And my C is going to be negative 8. So it's going to be 3r squared plus 2r minus 8 equals 0. Okay, now you're going to solve for r. So step 2, solve. How am I going to do this? You could do quadratic formula. No, I noticed that the a value is 3. It's not 1 anymore. So there's a good, we could try bottoms up, right? So see how this is a value is 3? You could try bottoms up factoring. So how do you do that? Rewrite the equation as if the 3 does not exist. So it's going to be r squared plus 2r. And then what you're going to do, the last term will no longer be negative 8. It's actually 3 times negative 8, which is negative 24. Equals 0. And then just try to factor this regularly. So this is r, r. And what two numbers multiply negative 24 and when added gives you positive 2? I think like 6 and 4. Positive 6 and negative 4. Yes. And then with bottoms up, you're only going to divide the 6 and the negative 4 by your original a value, 3. So divide only the 6 by 3, divide the -4 by 3, and then try to like simplify. So 6 divided by 3 comes out nicely as 2. And then -4 over 3 is a fraction that can no longer be reduced, right? Try to reduce it as much as you can. Since it cannot be reduced, what you're going to do next is put 3 in front of the r and leave the numerator alone. So this is going to be 3r minus 4 equals to 0. If all of this makes confusing, you can just do the quadratic formula. So you're going to get an r value of -2, and then another r value of positive 4/3. What do we know about these roots? They are distinct, right? They're two different values, and they are also real. Okay. Now we do have to now put it in the general form, and we got to, okay, so we got to most likely, here, let me put it in the general form. Okay, so it's going to be y equals c1, and then one of my roots is negative or positive 4/3. It doesn't matter what you put. You can switch these orders around, right? And then my other root was -2. Now we do have to find our C1 and C2 because we have initial condition. So we have two initial conditions, y of 0 equals to -6, and y prime of 0 equals to -18, right? So what we need is, so our y is C1 e raised to the 4/3 t plus C2 e to the -2t. And we got to find our y prime. So what is y prime? So what's the derivative of this C1e raised to the 4/3 t? Well, it's just e to the 4/3 t. Take the derivative of the power. What's the derivative of 4/3 t? 4/3. And then you still have that C1 because C1 is a constant, right? Plus, do the same thing here. It's going to be e to the -2t. And then what? Then you take the derivative of the power. What's the derivative of -2t? -2. And then C2 is a constant. If you want, you can just get rid of this plus and just turn it into a minus. Okay. We're going to use that to find C1, C2. So let's plug in our initial condition of your x is your t, so your t is going to be 0 and your y is going to be -6. So it's going to be -6 equals C1 e, and then replace your t with 0. Four-thirds times 0 is 0 plus C2e, -2 times 0 is 0. That's -6 equals C1, e raised to 0 is 1, e raised to 0 is 1, so you have C2. Let me just box it. It's not our answer. I just need a box so I don't get confused. And then let's plug in this initial condition. My t value is 0, and my y prime is -18. Let's see what we get. So this is going to be -18 equals 4/3 C1 e And then I'll just kind of do this. 4/3 times 0, that's 0, minus 2c2 e. Negative 2 times 0 is 0. So it's going to be negative 18. This is 4/3 c1. You know that e raised to 0 is 1, so minus 2 c2. E raised to 0 is 1. Let me box it, and we're going to somehow form a system equation. So I'm going to rewrite this system equation by moving the constant to the right. So it's going to be c1 plus c2 equals negative 6. I'm going to rewrite this as 4/3 c1 minus 2c2 equals negative 18. And what will I do next? I'm going to somehow do a system equation, and I'm going to do elimination. I think I'll get rid of the c2 by multiplying the first equation by 2. So this is going to be 2c1 plus 2c2 equals to 2 times negative 6 is negative 12. And I leave this alone. These cancels. What's 2 plus 4/3? Uh, I think it's 10/3. Yeah, 2 plus 4/3 is 10/3. So you get 10/3 C1 equals to negative 12 and negative 18 is negative 30. Get rid of the, you want to get C1 to get rid of the 10/3 by multiplying both sides by 3/10. So my C1 is negative 9. Let me box it. Now let's find our C2. Where could I put it? I think I'll put it here, but I'm going to put it in the original. So I'm going to replace my C1 with negative 9 plus C2 equals negative 6. Solve for C2 by adding 9. Adding 9 is C2 equals 9 minus 6 is 7, 8, 9. C2 is 3. Okay, so we have our C1, C2, and our two roots. So our final solution of this problem is going to be y equals, did I make a mistake? I think I did. Oh no, I did not. I was just looking at my solution. So my y is going to be negative 9 e, and then one of my roots was 4/3 t, and then it's plus 3 e to the negative 2t. And that is our final answer. Okay, let's do one more example, but this one is a little bit strange because it doesn't look like you can put it in the characteristic form. And maybe some people might think your roots might be imaginary. So let me show you. Okay. So example 5 says find the general solution of y prime minus 9y equals 0. So this is slightly different from the other one is because we're missing a y prime. We have a y double prime. We have no y prime and then the negative 9y. So keep that in mind. So what I'm going to do first is put it in the characteristic equation. So it's going to be, try to put it in this form. So it's going to be y double prime. And we're missing a y prime, so I'm going to just replace that with 0 y prime minus 9y equals to 0. Then figure out your a, b, and c. So my a is 1. My b is, we don't have a b, so it's 0. And my c is negative 9. So you can rewrite this as r squared plus 0r minus 9 equals 0. Or you could say it's the same thing as r squared minus 9. Okay. Step 2 is I'm going to solve. So it's going to be r squared minus 9 equals 0. You can just solve for r by adding 9 and taking the square root, or you can factor it out because it is a perfect square. This is r plus 3, r minus 3, and then that means our r is negative 3, and r is positive 3. What can you say about these two roots? They are definitely distinct, and they're definitely real. Okay, step 3, put it in the general form. So we don't have an initial condition, so we'll just leave our C1, C2 alone. And one of my roots was positive 3, and then my other roots was negative 3t. And there's your final answer. I lied. There's one more example. So this is where people might think it's actually one of your roots is imaginary, but it's not. So example 6, we have find the general solution of y prime minus 6y prime minus 2y equals 0. So we're not missing anything. So unlike the other one, we don't have to replace anything with a 0. So put it in step 1, put it in the characteristic form. Okay. So figure out our a, b, and c. So my a is 1, my b is negative 6, and my c is negative 2. So that's going to be r squared minus 6r minus 2 equals 0. Step 2, solve. So that's going to be r6 minus 6r minus 2 equals to 0. Okay, so does this factor? I don't think so. I can't think of two numbers that are multiply negative 2 when added gives you negative 6. So it does not factor. So use quadratic. Okay, so what's our a, b, and c? So my a is 1, my b is negative 6, and my c is negative 2. So it's going to be r equals negative b plus. So this is the quadratic formula, if you recall. It's going to be r equals negative. The opposite of negative b is negative. So that's positive 6 plus or minus root b squared. That's, I kind of did that in my head. Negative 6 squared is 36. Minus 4 times AC, I can't, so I'll just rewrite it. A is 1, C is negative 2. All over 2 times A. My A is 1. So when you put it all together, you're going to get R equals 6 plus or minus 36. And then negative 4 times 1 times negative 2 is positive 8. All over 2. So that's going to be R equals 6 plus or minus square root of 44. All over 2. So if you simplify this, this is going to be r equals 3 plus or minus square root of 11. My two roots are r equals 3 plus square root of 11, r equals 3 minus square root of 11. These are still technically real, right? That's an actual value. Uh, what is that? That's like, if you put that in the calculator, that is 6.3. And then if you put this in the calculator, that is negative 0.3. Okay, and we do not have initial conditions, so we do not have to find our C. So your final solution is going to be C1E, and then one of my roots was positive 3 plus square root of 11 t plus C2E, and then this is going to be 3 minus square root of 11 t. And this is your final answer. Okay, that wraps it up for this distinct real roots on here.